everyone, today we'll talk about the solution to the problem Defuse the Bomb. In this problem we're given some circular array and we want to calculate for every position the sum over some sliding window of k elements either before it or after it, depending on what the k is. And of course we can do it naively, which will take us n times k operations, because for every sliding window we'll have to calculate all the k elements to sum them up together, and we have n positions for us to do so. And this is not optimal. And the basic ideas for making it better would be either to calculate a single window and then get rid of this operation of calculating another window from scratch, because of course we know that if we move over by one element, then almost everything stays the same. We have to add this new element, remove this old element, and suddenly have the sum of the new sliding window. So this would be one approach. The other approach would be even more brute forcey, let's say, because we know that if we have prefix sums of the array, then we can calculate the sum of any subarray in constant time, because for any array, the sum over this subarray is just the sum of this prefix minus the sum of this prefix. And this will be the solution I'm going to show. An important thing to wonder in this problem is whether or not k can be bigger than n. So if we can, while taking, because the array is circular, while taking our subarray, if that subarray can loop around and lap itself at least once. In this case, it's not possible. Now, if it were to be possible, then we can either just remember the number of full rotations in this solution that I'm going to show, and the solution for the rolling sum will be essentially the same, because the adjustment doesn't change, only the starting sum will change. And now for the code, we will remember the length of our array. If k is 0, we are being told explicitly that everything should be 0, so we just return n zeros. Otherwise we calculate the prefix sums, and now we will just have to calculate the sums of the corresponding subarrays of size k. So the idea is, let's say for k bigger than 0 first, for every position I, we will take the difference between the prefix sum of I plus k and the prefix sum of I. And for k less than 0, we will have to do something else, but it'll look the same, so it'll look like the difference between some prefix sums. And here is a standard trick when working with circular arrays. Notice here that the prefix sum is built not over just the array, but over the array concatenated with itself. So this is an array and another copy of the array, because if this was the first copy and the second copy, then a subarray like this, let's say, is the subarray that takes this suffix and it takes this prefix, right? Because those things are the same, because those are two copies of the same string. And we have a prefix sum over that. So to calculate the other type of query, the other type of sum, we again take the difference between ith and I plus kth this time, but we do it starting from n. And of course here we have to use -1 to adjust the indices. So this is just some index games, not very difficult. Whether or not, for instance, if you adjust this range, then those indices will change. But the essence of both of those approaches is the same, and it hinges on the fact that we concatenate the array with itself, so that we don't have to worry about getting out of bounds. Of course, we use the fact that k does not exceed n, because otherwise we would have to reduce k to be smaller, and remember the number of full laps that we have used.